Question 10 says, visitors to Northern Ireland were asked to name their favourite tourist attraction. The table of probabilities based on the responses. Now, all of these were there apart from Musselton Temple and Derry City Walls. So these two probabilities were missing. To work out the 0.13s, we added all these probabilities up. So 0.3 plus 0.1 plus 0.14 plus 0.2. Once we got the total, which is 0.74, we took it away from 1, which is 0.26. Now, because the two of them would be the same, we have to divide it equally. So it's 0.26 divided by 2. And that means that each one of those would be 0.13. So the next question is, what is the probability a visitor named Ulster Museum was probably a visitor named Ulster Museum or Titanic Belfast? When you see or, you would usually add your probabilities up. So the probability of Ulster Museum is 0.1, Titanic Belfast, the probability is 0.14, and we add those two probabilities up, which is 0.24. So question C says, last week 1,800 visitors were asked to name their favourite tourist attraction. Estimate how many named Giant's Causeway. So the way you would do it is you get your probability for Giant's Causeway, 0.3, and you would multiply it with 1,800. And that would give you 540. So 540 visitors named Giant's Causeway. So question 11 says, a group of students visit a theme park on a school trip. The graph below shows their journey. They leave school at 9:30 a.m. and arrive back at 4 p.m. Which was the fastest stage on the journey to the theme park? So it involves just stage 1, stage 2, stage 3. I put stage 1 is the fastest. That is because it's got a steeper line between stage 1 and stage 3. So for question B, it says, how long did the students stay in the theme park? So the theme park is this top line here. So if we look down at the beginning of it, they were there at 11 o'clock. And when we look down here, it's between 3 and 4. So if we count that 1, 2, 3, 4, and then it's in between, it's at 3:30, so that'll be 4.5 hours. Calculate the average speed of the journey back to school. So this is the last part of it. This is this line here. So if we draw down here, we can see that it's half an hour or 30 minutes. And it was 20 miles they travelled. So in 30 minutes, they travelled 20 miles. So if we move that to 60 minutes, which is we multiply that by 2, so we multiply 20 by 2, which is 40 miles. So that just means they were travelling at 40 miles per hour. So question 12 is an indices question, and we've got y to the power of 8 divided by y squared. When it's division, we take away our indices. So it's y to the power of 8 take away 2, which is y to the power of 6. So for question B, it says solve the inequality. This is done like an algebra kind of question with an equal sign. It's moved around just exactly the same. So what we've got is 7x is greater than 3x, take away 12. So we want to get rid of the 3x and move it across to the left-hand side of that inequality. So when that 3x comes across, it becomes a minus 3x. So it's 7x, take away 3x. And that should become 4x. So we've got 4x is greater than minus 12. So we've got to get rid of this 4, and it's 4 times x. So the opposite of a times is divide. So we could say that minus 12 divided by 4. And that's what we've got here. X is greater than minus 12 divided by 4. And then we've got x is greater than minus 3. So that's it solved. Question 13 says rotate the shape 90 degrees anti-clockwise about 0, minus 2. So this is the shape it was shown in your question paper, and it's got a centre of rotation of 0, -2. So we plot that one, 0, -2. We get tracing paper and cover it up, and we just put a cross where 0, -2 is, and we would copy this one down on your tracing paper. You would put your pencil or pen on this cross here, and we do a quarter turn, because 90 degrees is a quarter. So anti-clockwise means it's going to the left, so you're rotating left in this one. So a quarter turn, when you quarter turn that one, it should fall on this particular point here, and we just copy it down from the tracing paper. Question 14 says, write the decimal number 19 as a binary number. So first of all, we write this down here. So we start with 1 on the right hand side, and we go 1 times 2 is 2, 2 times 2 is 4, 4 2s are 8, 8 2s are 16. Now we don't go any further than that. Next one would have been 32, but it's over the 19. So for this one, we start off by writing 1 at the 16, and we think about what do we need to add to make 19. We need 3 more. So 2 and 1 would make 3, and we just fill in the zeros with the rest of it. And that's what we've got there, 1 0 0 1 1. So for question B, it said rearrange H take away 3m equals y. You can do this in many different ways, but I've done it this way here, so you can see that this minus 3m gets moved across to the right hand side. Now if you think of opposites, the opposite of a minus is a plus, so we can look at it as y plus 3m, and that's what I've written here. The next one is I've taken the y across to the left hand side. So the y is being brought to the left hand side. This is a kind of positive y, so it changes to a minus when we move across. So that's h take away y, which is equal to 3m. Next part is we want to get rid of the 3 and 3 times m. So the opposite of a times is a divide. So we do h take away y divided by 3, which is this one. So m is equal to h take away y over 3. So for question 15, a regular polygon has exterior angles of size 15. How many sides has a polygon? Now, always be careful when you give these questions, differentiating between exterior angles and interior angles. So exterior angles, if you add all the exterior angles up outside a polygon, they should total 360 degrees. So we have one angle, which is exterior angle, which is 15 degrees. So to work out how many sides, that's 360 divided by 15, which is 24. That just means it's 24 exterior angles, which just means there's 24 sides. And that's the answer to that one. So question B, it says, Bailey thinks all regular pentagons are congruent. Is he correct? So congruent just means all the sides and all the angles are equal. They just may be in different positions. The answer there is no, because you can have big regular pentagons and small regular pentagons. Even though the angles may be the same, the sides may be different. So for question 16, Georgia rolls a dice number of times and records the outcome each time. She displays her results in this pie chart. Alice thinks Georgia's dice is biased. Bob disagrees. What information needed to decide who is correct? You basically need the number of trials that's been done to kind of get a more accurate result. The more trials you do, the more reliable your estimate becomes. So for question 17, it says draw the locus of all points which are the same distance from A and B. So these lines weren't here, it was just those 2 points that were in your question paper. So the first thing to do is to get a compass. And we take a compass like this and we line it up more than halfway. Put it on the point, one of the points here, and put it on more than halfway, and we would draw an arc. We would do exactly the same thing with the B. Do not change the size of the compass when you're doing this, and we would draw an arc. Make sure those two lines cross. So once you've done that, you get a ruler, and where they cross at these points, you would line this up and you would draw a straight line right through those points. So that means that no matter where in the line, that would just be the same distance. So if there's a point here, that would be the same distance from A to B. If there's a point here, that would be the same distance from A to B there, and it's the same for this point here.